The contribution of our paper lies in the understanding of the acceptance and usability of a soft robotic haptic feedback seat for autonomy level transitions in highly automated vehicles. This work is a collaboration between University College London and the Leibniz University of Hanover. In this paper, we show that our seat is capable of informing the driver of a takeover request through the activation of an array of embedded soft pneumatic actuators. We conducted a number of experiments aiming at thoroughly understanding both the acceptance and the usability of our haptic feedback seat. Static mechano-tactile haptic feedback is provided through a number of soft pneumatic actuators that are embedded in the driving seat. Each silicon-based soft actuator has a cylindrical shape with a diameter of 58 mm and a height of 60 mm. Reinforcement is provided through textile fabric that is embedded between different silicon layers. To facilitate the actuator design process, an analytical model is utilized as presented in the paper. This approach enables, for instance, achieving the required displacement and force. 12 actuators are then embedded into a commercially available driving seat, as you can see in this slide. 8 soft robots are integrated in the bottom of the seat, 4 on each side, and 2 are integrated in the back of the seat, 2 on each side. The actuators are connected to a control box with a PLC connected to commercially available pressure regulators. To evaluate the acceptance and usability of the haptic feedback driving seat, 3 experiments have been conducted. In experiment 1, the haptic feedback seat was explained and demonstrated to all participants. In experiment 2, the participants were driving along a scenario experiencing audio feedback similar to the feedback available in commercially available highly automated vehicles. In experiment 3, the participants were then presented with 5 driving scenarios that are very similar to the one in experiment 2, with the difference that the takeover request was initiated by the soft actuator and a wave-like pattern of the haptic feedback seat. After experiment 1, pre-measurements were taken for the acceptance rating, and after experiment 3, post-measurements were taken for the acceptance rating, as well as measurements were taken for the usability of the system. Within all scenarios, participants experienced driving along a multi-lane motorway in level 3 autonomy for a duration of between 23 to 69 seconds. Then an audio or haptic feedback signal is given to the participants indicating to take over control due to a traffic jam, a road incident, a police checkpoint, or obstacles on the road. The audio signal is similar to the signal played in commercially available highly automated vehicles today, such as this video gives you a demonstration of the actuation pattern of the soft robotic seat. The actuators integrated in the bottom of the seat resulted in an overlapping wave similar to a stadium wave, whereas the actuators in the seat back are simultaneously actuated either on the left or right hand side. The results for the usefulness and satisfaction, hence the overall acceptance of our device, show an overall rating for pre-measurements of at least 1 or higher, suggesting a clear inclination among participants towards anticipating a substantial degree of usefulness and satisfaction from the haptic feedback seat. The ratings assigned by participants to the seat after engaging in potential scenarios during experiment 3 indicate not only the fulfillment of these expectations, but also their surpassing. The results regarding the usability scores return that the haptic feedback seat with an average score of 89.67 surpasses the usability scores achieved by both visual and audio feedback systems. In conclusion, our paper presented the design and evaluation process of a haptic feedback driver seat equipped with an embedded array of soft pneumatic actuators. This haptic feedback seat is used to inform the driver of a takeover request through static mechano-tactile haptic feedback. The evaluation process engaged 21 participants who took part in various experiments within a driving simulator, experiencing both audio and haptic feedback from the seat. The outcomes of these evaluations showed that participants displayed considerable acceptance levels, which were then further amplified in post-measurements. With regards to the usability, the haptic feedback seat achieved an average of over 89 marks.